Hello everyone. In states of matter, we have completed first law, that is the Boyle's law. Now it's time to discuss the second law, that is the Charle's law. This Charle's law is also called as a law of volume because it is related to the volume, that's why. So firstly we'll discuss what about the history or who has introduced this law. This law is having the interesting story or interesting history for that one. So what is that history? I will tell you. Charles has originally worked for this law and Gay-Lussac's is another one scientist who has published, or we can say that he has confirmed this work and published it. Listen carefully. What is the point? Charles has originally worked for this law, but that work is not published by the Charles, and that same work confirmed and published by the Gay-Lussac's. That's why he got that credit, but he has given that credit to the Charles, and that's why this law of volume is called as a Charles law. That is the part of the history. Now what is the statement of this law? We will discuss the statement of this law. In that we can say that, as we have seen that in that Boyle's law, that was the temperature was the constant term. Here at constant pressure, what is the point? At constant pressure, volume of given mass of gas is directly proportional to the temperature. So what will be the equation? Equation will be, now see, what is the proportional mass of gas at constant pressure? Volume of a gas means volume is directly proportional to temperature. What is the constant term? Constant pressure is there, and second one they have given that given mass of gas means that N is also constant. If we remove this proportionality constant, then proportionality sign, then we will get the V is equal to K2T. Why we have taken K2? Because in a Boyle's law we have taken K1. That's why only for that purpose we have taken here K2 as a proportionality constant. So this is the one way to write this statement or to state that equation. So second way to write its statement is at constant, there is a no change in the constant term. So at constant pressure, volume of a given mass of a gas increases or decreases by 1/273.15 of its volume at 0 degree Celsius. For every degree of rise or fall of temperature. This is the equation, or this is the second way to write the statement of this law. So how to write its formula? Now say volume at 0 degree Celsius, that we are going to consider V0. Okay, V0 is the volume at 0 degree Celsius. VT is the volume at T degree Celsius. So how to write equation? Its equation will be volume at T degree Celsius is equal to initial temperature, means that is a 0 degree Celsius, whatever volume plus that decrease or increase by 273.15 at T degree Celsius into V0, because that is the change in the volume at T degree Celsius from the original volume. So this equation will be VT is equal to V0 plus T by 273.15 V0. Now see V0, these two are the constant terms. So Vt is equal to V0. We have taken that V0 common. So what will happen? In bracket 1 plus T divided by 273.15 will be there. Now what we are going to do? Just we have to make a same that base. That Vt is equal to V0 in bracket 273.15 into 1. That will be 273.15 plus T divided by 273.15. So these all terms are at the T degree Celsius or 0 degree Celsius, means Celsius terms are taken. Now if we consider the absolute temperature for that one we are going to convert it. So as we know that 0 degree Celsius, that is nothing but the 273.15 Kelvin. At T degree Celsius means what will happen? 273.15 plus T, that is the Kelvin term. So simply we are going to put this equation in this one. So what will happen? So for that one we are using one symbol, that is the T, and for this one we are using that T0, and here we are using T. Listen carefully. 0 degree Celsius means 273.15 Kelvin. For that one we are using the symbol, that is the T0. Clear? Now see next one. T degree Celsius means what will happen? That 0 degree Celsius 273.15. We are just converting into Kelvin. That's why 273.15 plus T will be there. And for that one we are using the symbol T. Now instead of this one we are using symbol. So what will be the equation? Vt is equal to V0 in bracket 273.15 plus T, means which symbol we have to use? That is the T. So T divided by 273.15, that symbol is T0. If we just simply modify this equation, then we will get that equation. Vt divided by V0 is equal to T by T0. So instead of Vt, if we are saying that it is the V2, and V0 means initial at 0 degree Celsius, that will be V1. So according to that concept, if we modify this equation will be V2 by V1 is equal to T2 by T1. So this is the final equation which we have to use for the numerical part. Thank you all of you. So here we have completed the Charles law also.